This video is going to go through drawing force diagrams and interpreting force diagrams. So our first example, on the guided practice slide, it says a block of weight W is being pulled to the right by a force P across a rough horizontal plane. Draw a force diagram to show all the forces acting on the block. So if we draw our rough horizontal plane, we can just do this by drawing a line, and we're going to draw our block on this plane. Now this block has a weight W, so the weight of the block that is pulling the block down, that force is going downwards. So for example, if you were to hold the block in your hand, you would feel that force in that downward direction, the weight in the downward direction. It says that the block is being pulled to the right by a force P. So in the right direction, parallel to our horizontal plane, we have got a force of P. Now because we're on a rough horizontal plane, when our plane is rough, this implies that there's going to be some friction. And the direction of the friction is going to be the opposite to the direction that it's being pushed. Or pulled. So it's being pulled to the right, which means we're going to experience some friction in the opposite direction. I'm going to call that F. Now the last force that we're going to write down is called the normal reaction force, and this is always in the opposite direction to the weight. So it's the normal reaction force, so that's the force perpendicular to the plane. So whenever an object moves, or if an object is still on a plane, there will always have the weight going down and then our opposite force, our normal reaction force, going upwards. So that is our force diagram for that first example. For part 2, we are given a force diagram showing the forces acting on this particle here. We're asked to draw a force diagram to represent the resultant force. So if we draw our particle and first consider our horizontal forces. Now the resultant force is the difference between these forces. Now the difference between 20 and 20 is 0. So the horizontal resultant force is 0, which means this particle is neither being pushed to the right or the left. The vertical forces, however, we've got 30 newtons in the upward direction, 10 newtons in the lower direction. So 30 subtract 10, we've got 20 newtons, a resultant force of 20 newtons in that vertical direction, which implies that the particle will be pushed upwards. For part B then, it says describe the motion of the particle. And we're going to use our resultant force diagram to do this. So as discussed, we've got an equal amount of force going in the right direction and the left direction, which means our particle is neither pushed to the right or the left, or accelerated to the right or the left. However, when we took the resultant force in that vertical direction, we found a resultant force of 20 newtons going upwards. So that means that the particle is accelerating upwards.